repeat myself. All right, so Thursday, so a week from today, that is the 29th. Yep, the 29th is when attendance, iClicker, and we'll have our first graded lab. All of those things will happen next Thursday. The reason for that is the first week is in flux. People aren't here, people are here, people add, people drop, all the good things. And then Tuesday we're finalizing groups. And so it just gives y'all some wiggle room. Now, I will ask iClicker questions today. So if you have already registered, that will be wonderful for a few reasons. You will be able to make sure that you're actually registered. So today and Tuesday, I will ask questions. So register as soon as you can, because I will upload those grades. I will also check out the attendance stuff and see if that's all working. And the reason for that is so you can see if it's working. This is kind of our little trial period. The sooner you get registered, then you actually get to check that yours is working and that you're actually getting points for it. So that come Thursday, I don't get a million emails saying I registered and I didn't get credit, et cetera, et cetera, et cetera. I don't want to deal with that. You don't want to deal with that. No one wants to deal with that. So, all that to say, register as soon as you can. I sent out the announcement with that. It's very straightforward. There's a link. You click it. You make an account. You will do this even if you have a physical iClicker. The reason for this is the easiest way for it to get connected to the class. They used to have an iClicker thing in web courses. Didn't work. Got a million emails last time when I tried to use that. So, this definitely works. If you make an account on here, if you have a physical one, they have kind of a guide for how you get that connected. So, any questions about iClicker or registration or anything like that? All right. It is very important considering it makes up 13% of your grade. So, please do it. Because this is how I both do attendance and this is how I do the iClicker credit. If you have a physical iClicker, if you have opted to use that, I will have a sheet of paper at the front of the room where you can sign your name. And that's kind of how we'll do attendance. You can do that at any point in class. But really, I don't know an alternative. And I say this, if I'm lucky, the physical iClicker will automatically say attendance because there's no way that this thing can pick up your signal if you're at home. But I don't know this for sure. So for today, I have no idea. It doesn't really have any documentation that the physical iClickers automatically give you attendance. Hopefully they do.
Want to try it?
I would love to. Here, what's your name?
Gabriel.
You said Gabriel?
Yeah.
Cool. I'm going to write down your name, and then I will check your attendance late. Yeah, you have your physical one. It's registered.
Yeah.
So today, I'll write down your name, and that'll be my check for whether or not it automatically does attendance or if we have to jump through some extra hoops. All right, cool. So, first half of class today, we're going to kind of get through the PowerPoints. Gabriel, physical iClicker. And then the second half, we are going to do a lab that is not a part of your course grade, but it's going to give you a preview into kind of what labs are going to look like. And we're going to be using Excel in it because Excel is a fantastic intro to kind of data management. If you do any experiment, you're collecting data. You got to record it somewhere. Excel has a lot of handy features in it for organizing data. It is not the best. If you're actually doing scientific research, Excel, you don't want to actually use that forever. But it is good as kind of an intro to get you kind of used to some things and lets you visualize the stuff. So there's that. I wasn't as diligent as I should have been, but I have done it now. So I told you after every class I upload the slides. So I had not done that until literally this morning, so I apologize for that. Generally, what I will do is at the end of class, before I leave this room, I'll upload them. That's my way of not forgetting. I forgot to do it last time. So moving forward, at the end of class, the slides are there. So if you want the updated ones for whatever reason, on whatever device you may prefer, bam, they're there. They are there as a PowerPoint and a PDF, and I want to kind of highlight some, because I often get questions, why is there a PowerPoint, why is there a PDF? Remember how I write on the slides? So the PowerPoint is here because you can download it. If you go into the preview tab, any writing I do, sometimes it looks okay, and sometimes it looks all janky. So this time I got lucky. But sometimes when I do the writing and the preview for PowerPoint, it looks all janky. The PDF, the reason PDFs exist is they look the same on any device no matter what. That's just kind of a nice thing for you all to know. If you ever need to submit something to anywhere and you want it to look exactly the way it's supposed to, save it as a PDF and upload that. There's a reason people ask for PDFs. It's because anytime you use a Word document or a PowerPoint or whatever Apple uses, it does some like formatting stuff, and that can get all messed up depending on where you upload it. PDFs are basically just like a picture. That's just good knowledge for you all to have. You will upload many documents in your life. If you have not already entered the wonderful world of health insurance, you will. It's the worst part about growing up. You get to upload all sorts of documents. So anywho, there's other things that are also terrible about growing up, but that's my least favorite by far. All right, so recap. Last class, we went through the syllabus. If you were not here, our class is pretty darn full then. But if you were not here, you're new to the class, whatever, check out the stream, check out the simple syllabus. Please look over those things before you send me any questions because it's all there. We then also got into vectors. And we did we talked about units and we talked about vectors. We said metric units are the best units. You convert things by multiplying by some power of 10 or dividing by some power of 10. If you go from big to small, you divide. If you go from small to big, you multiply. So, I think I have that backwards. If you're going from, big to small, you multiply. Yeah, anyway. And metric units are awesome. They're super convenient, super easy to use. We use these unit conversions because no one knows how many inches there are from here to their house. That was the analogy I used. All right, great. There's that. Did some practice. I gave you all a nice benchmark. 27 meters per second is 60 miles per hour. This is a handy one to kind of have somewhere in your head as we start to get into velocity. You're going to work with velocity a lot in this class. We'll get into that next week and all that. It's one of our bread and butter variables, so that's a good metric to have. Vectors, they tell you how much and in what direction. So they're an arrow. An arrow has a size and it points somewhere. The direction matters. So I gave some examples there. Then we broke them into components. I gave you all this vector notation where this I and this J, you could just pretend like it's X and it's Y. They have this little, so these things are technically called unit vectors. If you want to know exactly what that means, feel free to visit me and I can tell you more in detail. I'm not going to really get into it because it usually results in more confusion than it's worth. But the long and short of it is this X vector points in this X unit vector points in the X direction. The Y unit vector points in the Y direction. So if you put a number in front of it, it says how much in that direction. It's great. All right, and then we did some trigonometry. We drew some arrows. We then broke it into components, and we had a wonderful time, and we loved it with all our heart. All right, fantastic. Now we are going to do the exact opposite. So last class, or maybe we already did the opposite. Let me check. So we took a vector, we broke it into its X and Y. That was a good time. And you know what? It was so much fun. Let's make a random question about it. So I'll do this very often where I can just easily make up a question depending on where we're at progress-wise. So I have a vector with magnitude. Give me a number. 4. 4 meters per second. That points at an angle of, give me a number. 36 degrees above the, below the x-axis. What is the y component of this vector? So let me grab a calculator and actually get answers that work, and I'll make a multiple choice. The whole purpose of this is just so we can see if y'all remember from last time. You can start solving it now, but I'll generate the A, B, C, D, and then kind of send it out to see who's got their iClicker set up and all that. Pro tip, make certain your calculator is in degrees mode. Whatever calculator you might use, that was one of the things we mentioned. Radian degrees, make certain it's in degrees mode. So, is the answer 3.24 meters per second? Is it negative 3.24 meters per second? Is it negative 2.35 meters per second? Or is it positive 2.35 meters per second? All right. And now we get to experience The joy of iClickers. Boom.
This might just be me, but when I've tried to sign up for iClicker through the link a few times, it just tells me that my email's already used and reset my password. And then when I press reset my password, it never actually sends me the email. And I'm using my school email.
Okay, that's not great.
So, yeah, that's fine.
Yeah, that might be a contact iClicker thing. I know it's not super fun. I know, because I'm like, because that's on their end, and there's nothing I can really do about it.
Yeah, I figured, so I was like, okay, well, I definitely don't.
Yeah, it sucks.
But yeah, like,
It's so weird. Yeah. I was there to see from just the covers.
So,
Your identity for this.
it's like, I'm not
If
sure.
they did, it should send you the email.
Yeah, I think that's
All right. Okay, so currently I have 13 responses. So that is either an indication of people's progress or how many people have registered. Yeah. And then you reset the password and go there. So it sends an email to that.
And I go to others. Okay. Okay. Now I go to spam, junk.
Maybe if we're lucky, that's an email a little bit. If not, it's sadly because that's one of the things on there, and I have zero ability to do anything there.
Yeah.
And if you don't have your email, it won't sync this. What's that? Hey, it's always it. Yeah. Okay. Now and forever. Yeah. Yeah, so you have to have your dissertation services on? Yeah, that's a great point. Yes. No, that's a good point. So already getting to see some good technical challenges with iClicker. This is often what I get the most emails about during the semester, which is fine. It's important enough for me to also spend the time on this. It is the best service I've found to get responses from you all and get that kind of feedback. I've got 99 students in here. Anytime I ask a problem, I can maybe walk around and get feedback from like 6, 7, maybe 10 students. This lets me get feedback from everyone. That's the reason this thing exists. So it also makes everyone kind of pick something. It makes everyone kind of think. So there's a reason this exists, even for all the technical challenges, but that's why there's this wiggle room. A subset of you will encounter technical challenges. If there's common ones, I'll send out an email about it. So already there was one about location services. If you use it through the browser, make sure you have the app. The app, I think, hopefully will be much smoother. You will have to turn on your location services because this can be done remotely. The only way for me to see who's in class is to have your location. Like it's either that or I send around a sign-in sheet that everyone has to sign every single day, and that's a pain in the butt because then someone has to input that information. It's also easy for people just to write someone else's name. So again, reasons behind all these decisions. We'll see how it goes though. First time, there's going to be, we'll see if it's worth it. Yeah.
Just let me know, last semester, I had a professor, she used iClicker,
Okay.
and we would only answer the question if we were in class. I don't know how she did it, but
Yeah.
it was like a radio. If we were outside of it, we wouldn't accept the iClicker for her.
So it'll still require the location, probably. So probably still, yeah. So the question was, someone used iClicker and it only let you respond if you were within a certain area. So that would still require the location services. I am okay. I'm in fact on board with you all answering if you're not here. I recognize things come up in your life that prevent you all from showing up and things like that. So if you're still able to kind of tune in online and do that, you still get some of the points. You just don't get all the points because there's that attendance section as well. So I built some kind of buffer in there that if you can't make it, at least you can get something. Also, you get the 4 excused absences. So there's a lot of buffer in there for if things come up in life and you're not able to be in class. But that's the logic there. All right, this is looking decent enough. Looks like a lot of you all have actually, 61 of you all, so that's 2/3. Great job, everyone that did it. If you didn't, I get it. There's lots of things on my to-do list I also haven't gotten done. Next Thursday is your get it done by then date. So closing this out, let's kind of talk through the solution. So with you all, what I generally do, you already seen me do this. I will go around and check with groups and kind of hear what your answers are. In general, what I like to do is then find a group that got the answer right with the right reasoning and then have them explain it. It just gives you all a chance to kind of show what you know. So you probably see me do that already, but in this case, I haven't checked with anyone about this, so I'll just go through it. So we have a vector. Let's draw a picture. That's step 0. A vector with a magnitude of 4 that is below the x-axis with an angle of 36 degrees. There's a reason pictures are helpful. We can immediately see something about this. Does it point up or does it point down? It points down. So we automatically can tell that our vector is going to be negative. You can see that from the picture. Pictures help. They help you check your answer. So it's going to point down. We make a right triangle. That part of it points down. We have a triangle, a right triangle. We want to find the opposite side. That's the y component. So we're going to take our magnitude, which is this side. We're going to use SOHCAHTOA. SOHCAHTOA. We have the hypotenuse. We want the opposite, so we're going to use sine. So sine of theta equals opposite over hypotenuse. So step 0 was this. It kind of also had step 1 included in it. Step 2 was we were solving for the y component. Step 3 was we found the equation. Step 4, we're going to plug and chug. I'm doing all those steps. I didn't kind of write them explicitly as good as I should have, but they're all here. Something you're often going to see me do as well, I will, for you all, if this was an algebra-based course, I wouldn't do this. But for a calculus-based course, I'm going to recommend you all do the following. Do the algebra before you put in the numbers. And there's a reason for this. It's usually easier to keep track of the variables than it is to keep track of numbers. Once you put numbers in, you kind of forget what the numbers represent. You got a 3 here, a 7 here, a 10 here, and they all get mixed and matched after you start doing the algebra and you lose track of everything. Whereas when I do the algebra here with the variables, so if I want the opposite side, I multiply the hypotenuse over sine of theta, and it's much easier to kind of check your work that way. It's really hard to check your algebra if it's numbers in it. I'm just going to tell you, you'll see that as we do problems. And there's exceptions to this. There is some exceptions to these cases, but this is a good rule of thumb. Depending on your classes, you might get to the point, as you get farther along in your classes, we kind of stop seeing numbers, especially if you're a physics major. When you get to your upper level undergraduate physics classes, for those that are physics majors, you just stop using numbers altogether. It is literally just like find the equation for this. For a general case, because if you have the general equation, you can solve it for an infinite number of possibilities. Whereas if you just solve it with the numbers, that's a one-case scenario, and then you have to do it again and again and again every other time. So that's just a common thing that'll happen. So anywho, the opposite, which is our y, is just going to equal 4 times sine of 36. Now, this is going to give you a positive number. You could have put negative 36 if you had wanted to. But this is where that last part comes in. Does it make sense? We know it's supposed to be negative. So what you actually kind of have to do is using your picture, you have to know that it's going to be negative using that information. This is a really common thing with vectors. Vectors, the math often doesn't tell you whether it's positive or negative. The picture does. What's going on in the problem does. That's going to be a really common theme. Yeah? Yes, so you can put the negative 36 in there, in which case it will give you the negative. But some things that get a little tricky, what if instead this problem, yeah, so you can totally do that and that will work. The challenge you might run into is what if I give you a problem where it's, let's say it's like this. The angle is with respect to the negative y-axis. And you have to make a judgment call on whether to call it positive or negative for like the x component. And that's where it gets a little tricky. So my general rule of thumb when it comes to vectors, kind of put everything in as positive when it comes to these angles, and then assign the negatives after the fact. And honestly, it just, for me at least, that's easier cognitively. I don't have to remember all the different possible scenarios. But yeah, it can work, for sure. Okay, so this slide just kind of recaps all that stuff I already said. This can be a really common theme. I write a bunch of stuff, and then a slide that follows it's much more organized and nice, and that's there for a reason, because my handwriting is trash. All right. Let's see, we've already done this enough. I don't think we need to do another one. If you want to, feel free, but I think we're good at this point. Okay, we're gonna get some practice with this. So we just talked about vectors and breaking into components. Now I'm gonna teach you how to add vectors, and we're gonna see why you have to break it into components. So I'm gonna teach you how 2 ways, visually and numerically. And pro tip, doing them both results in you being able to check your work. Drawing a picture is always helpful, especially because drawing a picture is super easy. So great, I got 2 vectors here. I don't know anything about them numerically, but at least I got a picture. And I want to add these. I want to say R1 plus R2. What does that equal? All right, it's really simple, y'all. I've got the recipe right here. You draw the first vector, you start the next vector at the tip of the first vector, and then you keep doing that until you have all the vectors together. So let me show you what that means here. So I take R1 and I draw it. There it is in all its glory. Then the tip of it is this part right here. That's the tip of that vector. I then take R2 and I draw that one right there. It's not perfect, but it's good enough. What's my final vector? It's really simple. You start at the beginning, you find the end, and you draw an arrow from the beginning to the end. And boom, that's R1 plus R2. That's what R1 plus R2 will look like. If you have 5 vectors, just keep doing it. So let's just do a really jank example here. Say I had a vector this one, then I had a vector going down here, then I had a vector here. The final vector, you just start at the beginning, find the end, boom, that's your vector. That's it. Subtracting. Let's just focus on plussing right now, and then I'll tell you about subtracting. So, let's make up a problem. These are really easy to make up. I'm just going to draw 3 vectors, and you're going to, you know what? Here's a clicker one instead. No, I'm going to give you all practice one, then we'll do the clicker one. This way you have a chance to practice it and for people to kind of help you before it's worth any point. So, here's vector R1. Here's vector R2. Here's vector R3. Add those 3 vectors together and see what the final result is, just by drawing them. So remember, draw the first one, then start R2 right where that one ended, then start R3 right where that one ended, and then find the beginning, find the end, draw a line, and that's it. I'll go around and check and see how we're looking. And check with your group mates, because remember, there's only one right answer. Nice. Yeah. That's it. Okay, go ahead. Yeah, they get all mixed up. They get all mixed together. It gets hard to see. All right, you got R1 going up the left. You got it going up. You got R2 going down. Yeah. Yeah, and there's going to be, because these aren't precise, and I didn't give you exactly, these are roughly all the same size. All your answers might look very slightly different, but they should be at least roughly in the same direction. It's hard to be precise with this unless you had like a, what is that thing called that no one uses? The thing that measures angles? Protractor. If you get a protractor on you, you're better than me. But this will give you a sense. The whole point of your pictures, whenever you draw them, is to give you a sense of what will happen. We have to have the numbers to get precision. There's a reason we do the math. It's for the precision. All right, so it's looking good. This one's a little trickier to kind of ask people to show the answer. Something I'm going to go ahead and show you all. It's addition. The order doesn't matter. So just to show you all that the order doesn't matter, I'm actually going to do it backwards. So I'm going to draw R3. Then I'm going to draw R2. Then I'm going to draw R1. And my final result is that my vector points up to the left. The order of addition doesn't matter. You could have started with R2 and then done R1 and then done R3. In fact, let's just do that. R2, then R1, then R3. Look at that, you get an arrow that's exactly the same. So it's math, it's addition. It still follows the same rules. So that's kind of nice, because that's always the most common question I get with this, and it's a great question. What if it's a different order? Doesn't matter. It's addition. 2 plus 3 is the same as 3 plus 2. So, there you go. And then if you did it the other way. So, here's a clicker question on it. Try it out. Nice and simple. But if you can do this, you can easily check your work if I give you a math problem with vectors. And the cool thing with these ones is I get to see everyone's answer. I was like, me walking around isn't to like yell at people about anything, it's just to see what people are doing. And at any point during these questions, if you're unsure what to do, raise your hand. You got 3 people who can come by you and help you out. Again, you will have the benefit in this class where people can actually, the instructors can actually help you with problems, unlike in a lecture class where you're just a person in a mob of people. And you can ask questions, but people are always scared to ask questions when there's a mob of 250 people. And especially if it's a more complex question. I can like sit down with you all for like more than a minute and work with you on things in class. It's a crazy idea in a college class. You won't experience it like in any of your other ones. So, the only real downside to this class is if you're already an expert in physics, and at that case you just have to actually show up for extra time. But if you're an expert in physics, then it's an easy A. Whatever. All right, 5 more seconds. 5, 4, 3, 2, 1. It seems like our enrollment slowly is increasing, which is awesome. I'm assuming people are just like signing up during class, which is perfectly fine with me. Do note, and I mentioned this in the email, you get a 1-month free trial for iClicker. So it probably didn't make you pay anything when you first did it. In 1 month's time, that will run out. And if you signed up during class today, 1 month's time is probably during class. So I had that experience happen last time where a ton of people after class were like, my 1-month trial ran out in the middle of class, and I had to scramble. I'll send out announcements about that as we get close to 1 month to remind you, yes, you will have to pay for it. You don't want that to happen in the middle of class. It's $15. It is what it is. All right, cool. So looking at this, again, doesn't matter which one you pick. We'll see the answers in a second. So A goes down, B goes up. You get a vector that's pointing to the right. And so now we can start to see something in this specific problem. We can see something that's interesting. We get something called, when you notice symmetry, you can utilize that symmetry. So in this case, the symmetry here, A and B are the same size. A is pointed down just as much as B is pointed up. So what ends up happening? The up and down components cancel, i.e. the y components cancel. Didn't matter what happened with the x components, the y components canceled. That would also be true if I made this problem where A was like this, the same exact thing, but I made B kind of twice as long or 3 times as long, but it still went up just as high, the same result would happen. So you're starting to see something here that's going to be really, really, really important in your engineering and science career. X, Y, and Z are independent of each other. Mathematically, we can split them up and then treat them independently and then bring them all back together. So you can see here the y components cancel regardless of what the x components are. And so I'm saying that for some of you that might make sense. We're going to see that a lot more. And my goal by the end of this class is probably one of the most important things for you all to know is that x and y and z are independent of each other. And that's how you solve kind of any problem that has directionality to it, is you have to break it up. Which is why we have to deal with vectors, much to people's chagrin. Great, so this is the last one. I forgot to tell people. Woo, there it is. So you can see everyone's responses. It's okay if you get these things wrong. And there's the answer to the last one. That way it gives you the points. Points-wise, you barely get affected if you get it wrong. I just care about the effort. All right. So, all bold, all caps, because it's super important. If I have a vector, if I tell you I have a vector with magnitude 3 and another vector with magnitude 4, add them together, tell me the net vector, that problem's impossible. Because you have no idea which direction they're going. Direction matters when it comes to vectors. Easy examples to this. So here's a vector that's pointed to the right, that's 3. Here's a vector that's pointed to the right, that's 4. You know what? Let's just have you all do this. Draw me what the vector looks like for that. Draw me what the vector looks like for that. So, in one case, they're pointed the same direction. In another case, they're pointed opposite directions. You know what? Let's get crazy. Let's have one more where they are pointed perpendicular to each other. I want you to draw me what the final vector is if I add all three of these cases together to prove to yourself that direction matters. So visually, you can do this, just like we did before. It'll take you 5 seconds. See if you can figure out what all 3 answers are. The magnitudes are identical in every single case, but the directions have changed, and that's the only thing I changed. So add. See what y'all get? Something I am surprised about is how much people still use paper. It's interesting. That's just an interesting note for me. I thought people had all switched to technology, like devices at this point. So this will be a drawing one. You can do the math. You can do the math on these ones if you want to, but just drawing it up. Either way is fine. If you know that they are perpendicular, I'll do both because I think that is an interesting point. And that's one of the benefits is I get to see people reminded that there's multiple ways when I go around and see how people interact with it. And check with your group members. Like I'm going to show you the answer, but you can figure out if you're right way sooner if you just look next to you and the person has that same answer as you. That's a good sign. There's a reason you have group members. Check your work. This is one of the best ways to make sure you don't make a mistake is literally have another human being do the same problem. Oh, and if y'all have your name cards, if you have them out, that's just going to help you remember your names. Otherwise, I will just kind of go around and ask you what your name is. But if it's in writing, that just helps me. It also probably helps your group members not have to ask what your name is because they probably forgot to or they never learned it. You know, one of those two. You are? Roy. This makes it so efficient. And Cody. Roy and Cody. All right. Instead of going for each class, I just like all we can see is try to solve points that we will never see. So we will carry around the other side. Is it a perfect triangle?
I know that
There's 3, 4, 5.
I know that there's one with 13.
Oh, wait, I picked such a good numbers for this. Oh, wow, nice of me. I didn't realize this. All right. So, yeah, visually, if you all add these two, they go one after the other, and you get 3 and 4, and you get one that's size 7. They add. Wow. This one is 3, and then it's 4 backwards, so you get a positive 3, and then you get a negative 4. So the result of this, if we go tip to tail, we get a vector that's pointed 1 to the left. So you could call that like a negative 1 if you're in the x direction. And this green is absolutely atrocious to read, so let's do a darker green. And then I gave you all a really nice one here, because it's a 3, 4, 5 triangle. So you have a 3 here, then you have a 4 here. And so that makes this side the hypotenuse, and it does end up being a 3, 4, 5 triangle. You can use Pythagorean's theorem. The long story short here, though, is that every single answer here is drastically different. 7 is not the same as -1 is not the same as 5, and they're all pointing in different directions. So, direction matters a lot. And for the vast majority of variables we introduce in this class, they have a direction associated with them. Velocity, position, acceleration. Time does not have a direction, probably, maybe. We're not going to associate a direction with time. But anywho. All right, great visualization of it. Woohoo. There it is. It shows the things. So what this is showing is that the way you can mathematically add vectors is by breaking them into their x and y components and then adding those together. So let me give a problem on that. Let me just kind of walk through one, and then I'll give you all a clicker question to kind of work through on that. So I actually have to make up numbers now. So, let's use this picture because it's way nicer than anything I'm going to draw. Yeah, it didn't get the arrow, did it? I trusted in them being grouped. All right. So let's make a magnitude of, give me a number. 10. Sorry, 10, 1. I heard 10 first. We're just going to keep, let's make this 10 meters. B looks like it's roughly the same size, so we're going to call that one 10. We don't get to make up a new number for that. I need to make up some angles. Roughly, what does this angle look like? I do need something that's reasonable. What was it? 30? Yeah, that's fine. That's fine enough for me. All right, so that's 30 degrees, and then we're going to make this angle, because we got to make a couple right triangles here. So this vector B, we're going to also make into a right triangle. Roughly what angle would someone say that is? 55. 55 it is. Again, I'm not looking for exactness. I just need something that's roughly reasonable. Okay. So, great. We have learned how to draw them, and that's what this is showing. Let's go ahead and learn how to get the exact numerical answer. In this case, it's not just adding 10 plus 10, or it's not just doing Pythagorean's theorem of 10 squared plus 10 squared. How do I get vector r, the combination of the two, mathematically? Here's what you do. You get the x component. Let's draw it in orange because that one's orange. You're going to get the x component of A. What do we call the x component of A? AX. How nice is that, right? Anytime you put a little subscript next to something, you kind of can think of it like an adjective. This is the x component of A. You're going to find that these can get crazy. So you can have the x component of object 1 in the beginning. You can have a ton of subscripts next to things, and you might need all of them. If I have multiple objects and time is changing, we're going to see that in the future. But I just want to mention this notation to you all. These little subscripts, they're basically like adjectives. So in that case of AX1I, that would be the x component of object. So x1I is the x component of object 1 initially. We'll see those in the future, but I just want to point that out to y'all now. The more I mention something, the easier it'll be to remember, the less surprising it'll be when it pops up later. All right, great. So we're going to get the x component of A, and then we're going to get the x component of B. That's not A. X component of B. And you can see visually here that if I kind of add those together, I will get the x component of R. You can kind of see how those two visually add together to give you an x component. So the logic here can be much easier to see visually than if I just told you all and said it is what it is. So great, we can get the x component of R. We can repeat that same process and get the y component of A and get the y component of B. Give myself a little bit more space. And the same logic follows. I can add these together to get the y component of R. So let me remind you all that B is 10. Okay. See if y'all can figure it out. Find the x component of R, find the y component of R. I'm going to go ahead and generate the answer, and I'm going to write it up here so y'all can check your work. If you're not getting the right answer, again, work together with your peers Work together, see if one of you has the right, one of you got it. So I'm going to give you the answer so you know when you did it correctly. But yeah, it's multiple pieces. Find the x components of each. Add them together to get Rx. Find the y components of each. Add those together. So let me even make that really explicit here. Rx equals Ax plus Bx. Ry equals Ay plus By. So there's a couple steps here. Is this the most fun experience? Probably not. But you have to be able to do this. There is no getting around this. This is a skill you have to work in a world that has multiple dimensions, which is the world you live in. So tough luck on that if you're hoping for something different. Hypotenuse. Yeah, 10 meters is the hypotenuse of, and you know what, let me move those to make this easier to understand. That is a great, thank you for asking. So A here is 10 meters, B here is 10 meters. I'll put them next to it so it's a little easier to read. The angle of A is 30, the angle of B is 55 with respect to the x-axis. All right, so these are the answers. And you know what? If you're feeling especially ambitious, I'm going to give you all the angle of R. R angle, which is this right here. See if y'all can figure that out as well. I haven't told you what to do. I will at some point. But I think most of y'all can figure it out. Boom. Answer. 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 Try it out. Work together. There's many, well, 2, 3 steps. And I'm loving that I'm seeing people are writing out a lot of this information. That people are writing what AX is and people are writing what AY is. The more you do that, again, the less likely you are to make a mistake. Or if you do make a mistake, the easier it is to check your work. The more you write, the less work your brain has to do. I did things very quickly up here and I didn't write as much to get these answers. That made it more likely that I made a mistake. You're going to see whenever I make problems like this, you will see me make mistakes. Guarantee you. The quicker I go, the more likely I am to make a mistake. I follow the same rules as you do. We're all humans. How we feel? It's all jiving. Comments, questions, concerns? Cool. Oh, you're just slightly different. I do round. I probably did a little bit of rounding. Yeah. Oh, nice. Yeah, it's probably because when I plugged in my calculator. I put 195 instead of 1915. There we go. Look at that. See, there was a very, very small error I made. It's 42.5 exactly because I accidentally typed in 13.195 instead of 13.1915. I was able to catch that because my calculator had that kind of in writing, and I was able to kind of check that and look back and see that I used the right number. If I didn't have my calculator, it didn't have. All right, looking good, y'all. Looking good. So the beautiful thing is you all know if you got the right answer because I put them up here. So just to break it into pieces, so AX will end up being 10 meters times cosine of 30. Now, I'm actually going to pause here because at this point, I don't want us to get in a bad habit that's really common in Physics 1. A habit people get into is that the x component is always cosine. A lot of the problem, I think every problem I've given you up to this point has been cosine. I'm going to very quickly take a slight deep, and I'm going to mention it several times. It's a really bad habit that people can get into because often I give you all this angle with respect to the x-axis. But let me just quickly give you all a counterexample. If I gave you all a vector like this, and I gave you this vector was 30, and this was 10 meters, the x component is not cosine. If I gave you this angle in this picture here where it's pointed down and to the right, the x component would be sine. So I just want to mention that, just as a quick aside, the x component is not always cosine. It's very tempting to fall into that pattern, but you should always kind of be doing that check in your head. It's cosine if it's the adjacent side. It's sine if it's the opposite side. Anyway, so we will see examples where that is not the case, where it's not cosine. But I just want to mention that now. All right, someone tell me what this is. 8.66. Great. Same thing. And you kind of get a preference here. I tend to keep my A's together and I keep my B's together. You could have done AX and then BX, whatever. However you wrote it, doesn't really matter. The Y component would be sine of 30. Someone tell me what that is. Oh, that's so good. Oh yeah, sine of 30 is 1/2. Unit circle is a very helpful thing for you all to know to kind of check your answers. Sine of 30 is 1/2. 5 meters, all right, and then we do BX and we do BY, same exact logic, but with different numbers. So 10 times cosine of 55. Someone tell me that. 5.73. As long as you're within 1 or 2%, I'm not too worried. All right, BY, that's 8.9. Thank you. 8.19. And you can see if I add the components here, you get the answer with surrounding kind of adjusted for. Now the angle I didn't mention, but someone who got the angle, how'd you do it? I don't care who. Yeah. Using inverse tan. So tangent of theta equals the opposite over the adjacent. In this case, that means that theta will equal tangent inverse. Oh, I did the ghost thing. That's terrible. All right. Tangent inverse of y over x. So you have the rx. You know what? Yeah. So this is something unfortunate. You will see me do this. If ever my hand kind of flubs the screen and it switches slides, it breaks PowerPoint. And I have to reopen it. It's very sad for me. For you, I guess it gives you a tiny bit of a break. So I'm going to close this and reopen it. There's literally no other solution. The other fun thing is the more I write in a PowerPoint, the longer it takes to save because writing is not an efficient thing for PowerPoint to save. It's a fun little programming thing. Letters are nice little, this is kind of fun little application stuff. If you think about PowerPoint and how it would save a file, letters have a set kind of easy size to them and they can kind of scale things. Writing could be anything, and so it's not as efficient to save the writing. It's just interesting if you're in programming and stuff like that. That's always anytime you're working with a program and you think, why does this do that? It's a good application to get into, especially in your all's majors, depending on what your interests and major are. Ask those questions. That's what kind of separates someone that's really into it and someone that's just doing it for the money. Because you will make more money than other people in this field. All right, so you can see here it didn't even save that stuff. Boom. Fingers crossed I don't mess it up again. Tangent inverse of ry over rx. All right, cool. You plug that in, you get the answer. Cool. All right. Let's do a really easy one. You're going to notice the iClickers are really easy. They're quick on purpose. But it's just a quick check for me to get everyone's things. I give you the vectors. I already give them in components. This one now, I guess it's in the notation. So all you need to remember here is that I is the x component and j is the y component. That's all you need to remember to be able to kind of translate what we just did to this problem. And again, check with the people around you. You have people you can check with. If you put a different answer as them, which at this point is unlikely because everyone's picking the exact same answer, that's good. That means learning happened, right? Or it was so easy you didn't need to learn anything. Either way, I'm happy. And if you're done and you're bored, my challenge to you, draw these vectors as well. Draw it visually. I'm going to do the same thing. This is a good practice kind of check thing. Can you do it mathematically? Can you do it visually? Because that's kind of ultimately the skill set that we're doing today. Can you draw these vectors accurately? And you'll be able to kind of check your work. So I will do both. So you can check that if you're done. Whatever your picture is should match what your answer is. So, yeah, it's a really good check for you all. All right, I'll give this till 2:30, so 10 more seconds, and then I'll kind of do the math part. Feel free to keep doing the picture part. I'll do that after. 5, 4, 3, 2, 1. All right, so in this case, the math part is easier because the numbers are all there. So we add the x components together. So a plus b, we're going to add this and this. And then we're going to add the y components together because they're separate. So this new vector, whatever name it is, call it whatever you want, r, x, 7, smiley face. I didn't say a name to it, so you can call it what you want. That's going to be negative 2 I hat, because 3 plus negative 5 is negative 2. And then 2 plus 4 is going to be 6 j hat. Fantastic. There it is. We're looking really good on this. So good. And then the harder one is drawing the picture. So, drawing A, it goes to the right 3 and it goes up 2. So it goes to the right 3 and it goes up 2, so it should just kind of go a little bit more right than up. That's roughly how I'm going to draw it. That's probably not perfect, but it's good enough. So that's A. And then I have B, which is going to the left 5. So I'm going to go to the left 5, and then I'm going to go up 4, and I put my thing in a very unfortunate spot because I'm in the way. All right, so I'm going to go to the left 5, which is more. A was to the right 3, so I need to go farther than that. And then I need to go up 4, which is bigger than that. So at some point, drawing the components is kind of necessary to draw the vectors, to at least do it accurately. And then the end result is I go from here up to here, and we can see, yep, I go to the left 2, and then I go up that much. So that's the final result. This and this are the same thing. This is 2. This is 6. There we go. Nice little check there. All works together. The beautiful thing in physics is if there's two ways to solve a problem, they should both work. If they don't work, then something is like, if you are following correct logic, it doesn't matter what path you take, you'll get to the final result. As long as the logic you're using is correct. And we're going to see many examples in this class where there's 2 or 3 different ways to solve a problem. It doesn't matter which one you pick. As long as your logic is accurate, you'll get to the right answer. But you can use one of the other ways to check your work. All right. This is one of the problem set problems. Problem set 1. I just didn't put the exact thing here. Let me just pull it up. That's not it. So I can tell you exactly which problem this is. Remember that problem set is kind of the go-to place for practicing stuff in this class. And so I think this is actually the last problem in it. This first chunk, oh, it's almost the last problem. All right, it's got a ton of words. Did I use that many words? No, I literally just said use the picture. Words in the problem set 1, go with this picture. That's the beauty of a picture. I could either write like a whole paragraph or I could draw a picture. So anyway, this is problem set 1, number 11. That's the only reason I did this. Problem set number 1, number 11, whatever. All right, let me read this to you all, and let me make it a little bit bigger. I have one boat pulling with 5,000 units. It is not clear here what a unit is. I'll tell you in the future. Our unit for force will be newtons, but for now, don't worry about it. So 5,000 units at an angle of 12 degrees with respect to the vertical, to the left of the positive y-axis. And you have a boat pulling with 4,000 units with an angle of 15 degrees with respect to the positive y-axis. Find the net pulling unit. Combine those two vectors. And I want two things here. I want how the magnitude of it, and I want the angle. Anytime I ask for a vector, generally that's going to be a rule of thumb. You want both things, because remember, direction matters, and also how big it is matters. So, see if y'all can figure this out. If you want to know what the answer is, it's in the problem set. So, try it out. See if you can get the same answer as someone else. We'll go around and work with you all. If you have questions, call me over. Or anyone, any of the TAs. If you're scared of me, they're kind of kinder. And I love that I see people drawing the picture even though it's on the screen. That's a great idea, unless you want to be swiveling your head every 5 seconds to look at the screen. If you put it on your paper, again, it just makes your life easier. It is no problem to not do so, but I just really want to emphasize drawing the picture is always so handy on whatever you're solving the problem on. It almost always will make your life easier. So, if you do it visually, we're adding that. So that's what we're doing here. We're adding 5,000. We did the last one. We have to do each of those vectors before we do the section. Yeah, that's all you do. Yeah, that's perfect.
Yeah, I feel like it's like you can't really solve any of this unless you know this, like the hypotenuse.
So this problem is the same as the one where we added the vectors before. But so remember, they're vectors, you are adding them. It's asking what's the total. The word net just means sum. You're going to see that word a lot. That means sum. That means add. We can't just add 4,000 and 5,000 because their direction matters. So what do we have to do? Break them into components. And you better be careful with directions. That's kind of a hint to you all. Direction matters. And the x component and the y component, there's positives and there's negatives. So keep that in mind. Yeah. Yes, yes. Yeah, this 5,000 units is the hypotenuse of this left arrow. The 4,000 units is the hypotenuse of the right arrow. Yes, that's what those, that's the length of those arrows. Of this. These are force vectors. I haven't introduced force, that's what we just call them units. But it is force. What those are. Yeah, what's up?
So you would do what you were doing in the last, just to find it,
Yeah.
and then, but you said the direction matters.
Yes, so are they, so when it comes to y component, is it, so here, did you find the x component or the y component? So sine finds which side? Because the x in this case is the opposite. Yeah, so this is one of those, yeah. And so then we look at our picture. Is the arrow to the left or to the right? In that specific case. So positive or negative. So you have to assign that negative. Yeah. Yep. So once you all find the components, so let me even draw this on here. Give you all kind of a checkpoint here. So this one, if you break into components, you get the x component going to the, you have the x component there and the y component there. So when you break into components, the math will not tell you whether it's positive or negative. It'll give you something, but I'm going to tell you it's probably not going to be right. Look at the y component. Is it up or is it down? Look at the x component. Is it right or is it left? That's how you decide positives or negatives. The math won't tell you. You have to decide that based on the picture. So, and again, check with the people around you.
This way, it would be.
I'm here as a resource, but so are your peers. There's a lot more. Your peers are much closer than I am.
Yeah.
All right, how are we feeling here? All right, so let's do this. So we have two arrows, two vectors. We're just adding. Who cares what the vectors are? We just know that we're going to add them. So what's that first step we have to do? We can't just add 4,000 and 5,000. So what do we have to do before adding? Yeah, the x components and the y components of each one. Yep, each one has their own x component, each one has their own y component. Yeah, so let me. So to kind of draw this out, you got your 4,000 here, and that's going to have an x component, and that's going to have a y component. You got your 5,000 here. That's going to have a y component. That's going to have an x component. Get used to drawing right triangles. They're going to be your favorite shape in this class. You're going to be seeing them a lot. But see, if this is a lecture class, you'd have the joy of figuring this out outside of class. For good or for bad, I would quickly solve through this in class and then hope that you followed along, and it might seem like it makes sense, but trust me, you really know when you know something when you do it yourself. You haven't experienced that? Yeah, driving a car is one of those easy examples. You all drove in a car, you sat in a car as a passenger for 14 years of your life. The second you got in front of that steering wheel, it's a way different experience. Well, at least it was for me. I remember being very scared. All right. And then I got up and back. Yep. It is. Yep. You added this number and this number? Negative 1,039 and positive 1,035. You might want to check. What? Just using your, when you put down the calculator, what should, you can do that in your head. You added these two, right? You can do that in your head. Yep. So that was just a calculator thing. So that's your new x. So that gets negative 4. Put that off to the side. Oh, I thought this was negative 4,800. Okay. I didn't know that was so rule of thumb. If you're going to x comma y, that's why. Yeah. That's why. That's why I was so confused. I was like, how did you get negative 4,800? Then you added the y components. Yeah. That's your x. So your vector is that's your x component. That's your y component. And you can see that visually. The x of this one seems to be pulling to the left, but the same amount that one's pulling to the right. So they almost perfectly cancel each other. Not quite, but almost. Yeah. What's up? Oh my gosh, what a chump. All right, see, I made a mistake. I put the units on the wrong side. This should be 5,000, this should be 4,000. I told you all, you're going to see me make these mistakes. And that would mess everything up. So, this is where double checking, going slowly, all that kind of stuff helps you avoid these things. They'll still happen. Yeah. I think you report that. So I think you got a different one. Left one is that's the X component, right? Or the Y component? So this is just oh, that's not your Y component. So you got a different Y component. So you got 4,800. Yeah. And if we look at this picture, this is, and you can also kind of check this, if you square this and square this, it gives you 5,000. Yeah.
I mean, I got that going this way. Is that what it's asking? Or is it?
That's one side.
Yeah, I was saying
Yeah. So, let's see, what can I check? So the final answer, so y'all can check your work. Remember, the beautiful thing about these problem sets is the answers are right here. I don't have the answer memorized. You know what? I'm actually going to take the answer. This is roughly what... Yeah, your answer's better. I like yours better. All right, so the answer to this one, if I had to call this new vector, let's call this new vector... you know what? Let's just use the term F net, the net force. That's what I'm going to call the total. Because that's what you'll see eventually. It will be -4 in the I hat plus 8,000. What was it, Logan? 753 in the J hat. And again, if we look at our picture, this answer kind of makes sense. The one on the left is pulling a lot up with 5,000. The one on the right is pulling a lot up with 4,000. So those are roughly going to add. But clearly they're not going to add to 9,000 because our answer is not 9,000. So anywho, I'm going to keep circulating around. If you're done, you just got to get to start your break earlier because after this problem, we'll have a break and then we'll do a kind of our first lab. That's not worth any points. So I'm still here to help y'all. Our break won't start until 9:20. So if you finished early, you just get to start your break 2 minutes early.
It goes combined. So you need to
So they are different.
And he just rounded it to later.
So these are actually so at this point, I'm going to start working through the problem, and that'll then kind of get us nicely into the break. So I need to find. Let's label these. Let's call this vector 1. Let's call this one vector 2. Or actually A and B. I like A and B better. A and B. So that's AX. This is BX. This is AY. This is BY. Remember, you have to get all the components. So if you want AX, and this is where I kind of warned you all about this before, AX here is not the adjacent side. AX is the opposite side. When you all look at this picture, AX is not going to be 5,000 cosine. It is going to be 5,000 sine of 12. Because it is the opposite side. This is where I warned you all, the X component is not always cosine. And it's really easy to get into that habit because a lot of the problems you see it will be. But not always. So BX here is going to be 4,000 sine of 15. You want to get AY? I've run out of room here. AY is going to be 5,000 times cosine of 12. BY is going to be 4,000 times cosine of 15. And then there's something very, very important here that the math doesn't tell you. AX is to the left. AX is to the left, not the right. So if you plug those numbers in, someone tell me, what does this equal?
But you have to know.
What is 5,000 times sine of 12? Many of you have plugged it in already. 1,039. You need to chuck a negative sign in front of that because it's to the left. Because it's to the left. So when you add your x components and when you add your y components, it will be negative 1,039. AX plus BX equals negative 1,039 plus positive 1,035. The y component will be, someone tell me what's AY? $3,863. AY is up, BY is up. They're both positive. So what's BY? 4,893? Is that right?
99. So 93.
Thanks. All right. So, here we're at. We will go ahead and kind of take a break now. We're not going to reconvene until 9:25. 12 minutes. This gives me time. If there's anyone who has questions on this, that still has questions, you're not kind of eating into the break too much. But if you're done with it, do whatever you want to do. We'll reconvene at 9:25. And at that point, we'll start doing a lab. It'll be a great time. But call me over if you have questions. Or it's here in LA. Or where.
Like in the test, if you
Yeah.
have to like do
As long as you're within 1 or 2%, you're good. And 1 to 2% is like Sure. That's probably it. Yeah, I'm not too worried. Yeah, it's a good exercise, and also, as long as you're within 1 to 2%, I'm a happy camper. So that's if you got like 8,754, that one actually might be more accurate than mine. As long as you're within 1 to 2%, you're good. I care about the process, the final answer, rounding, all that. I'm not worried about the rounding. If this is a real deal, you're working for a company, you would do this within a computer that would get you way higher precision. You'd be more careful. We're not worried about that. Process.
I will try to be back. I'm not running about one.
You're good? What's up, Jacob? I'll mute this during the break because. Yep.
I've not done many proper labs in the lab part of this.
So it's going to be really straightforward. So I'll straight up tell you what we're doing today. Any lab that we're doing is going to be really simple. The instructions. So you have to remember, everyone here is plugging in the same campus. One thing we're going to do for lab, like I said. What we're going to do for today, we're going to draw some coffee filters. You get to pick 3 heights. Use a ruler to measure those heights. Time it, and then we'll input that into Excel, and then I'll do some Excel. Teach y'all some Excel things. So today's anything I have you all measuring stuff will be really straightforward, and I will, moving forward, if it's complicated, you'll have written instructions. And yeah. So everyone's kind of, if there's anything you're concerned about, there's probably gonna be a commonality for everyone, and so I'll have supports and stuff like that. Yeah, it's gonna go super smooth. Yeah, the labs here should go super smooth. Fingers crossed. If they don't, I will adjust things on the fly for everyone. Yeah, what's your name? Matt, pleasure.
I came in late and I was told to tell you that I had an eye clicker.
Great.
Do I have to register this?
No, so today it doesn't really matter that. Have you been responding with it?
Yes.
Cool. Today the points don't really matter. Today, so I at least had one person with a physical eye clicker. I want to check if it automatically gives you attendance. For that, my hope is that the software is smart and knows that if someone's using a physical one, that they're here and gives attendance.
The app was saying that it's showing up.
So I'm hoping. Oh, When did you show up? How? All right. I'm gonna look into it for you and for the other person. For physical ones, I will just have a sign-in sheet or something if that's the case. It's not ideal, but I don't know of any other simple thing. That'll work. Yeah, I won't penalize you for that. Yeah, and I might also just flag the people that have physical eye clickers. I should be able to check that somewhere. And then I might just have to do that later on. Like, if you respond to class, I'm going to do it right here. You won't. How you doing? Is it working out the way you want it to? Yes. Yep. Because it's pointed. That's it. Yep. Direction matters. Yeah.
So, I mean, this is
It's just thinking about it differently. That's something I
All right. So hopefully everyone's back. It's looking pretty full there. I also got to do some organizing and planning on my end during this. So I'm excited to see how this goes. Let's phrase it that way. I'm excited to see how this goes. This lab is going to be very simple. It's going to be absolutely trivial, and it does have a purpose. So the purpose of this lab is to get us used to collecting data, inputting data, and analyzing data, which sounds way more intimidating than it's going to be. And I've already made mention to this. Excel or Google Sheets is a great intro, a great kind of intro utility for doing data analysis. Honestly, for the vast majority of you all, Google Sheets will accomplish 99% of what you ever need to do in life. I use it obviously for the grades for this class. So there's lots of like manual manipulations I have to do to your all's grades. That's a bunch of data. I have 99 students with however many assignments that get generated. When I download the gradebook, it's called a CSV file. You open CSV files, you can open them in Notepad, but I don't recommend it because it looks like a hot mess. You can open them in Excel or Google Sheets, and you can do all sorts of manipulations with the data in a really easy way. You all will be working with data. I cannot imagine, my hope with these labs, this is a major component, the major skill, honestly, in these labs is working with data within contexts of physics that we've talked about. So, to that end, our lab today is going to be absolutely like one of the simplest things ever. here's what you're going to be doing. You will get a coffee filter and you will drop it. And you will record the height and how long it takes to hit the floor. And that's the data you're going to be collecting. Sounds like what a wait, like, that's so stupid. It's so simple. The purpose of this isn't to discover how a coffee filter falls. That's just the context for us working with data, because the data skill is one that we're going to be using for the rest of this. So, in a little bit, someone from your group will come up and grab a coffee filter. You will not be submitting this assignment today. In the future, you will be, and when we start doing that, I'll tell you what that's going to look like. There'll be a thing in web courses where you'll like self-assign to a group, and then you'll get a group. Then the TA only has to put one grade in for your group. We'll get to all that later. For now, we're not worried about that. There's no submission, there's nothing like that, but someone in your group will need access to a computer. Thank goodness every group's got a computer right in front of them no matter what. So you can log. I highly recommend. It's very unlikely that any of your laptop screens are as big as the one in front of you. Feel free to have someone using a laptop, but the screen in front of you is probably bigger. Whatever. I don't really care what you use as long as someone has a screen in front of them. So make certain someone's logging into something. We're going to talk about group roles in a bit throughout the semester. So you have 3 people in your group. At all points, someone should be doing something. Like I say, someone. 3 people is enough that you generally won't have one person just sitting around doing nothing. That's kind of 3 is a nice number for that. But if you do have someone not doing much, at least the other 2 can still get stuff done. Whatever. There's a few roles that we can talk. There's like the person responsible for inputting data. There's the person actually handling the equipment. Reason why group work exists in this world. It might have been possible for us to achieve what we have by people working individually, but it would not be in the year 2024. I have no idea how much longer it would have taken. People work in groups because it's efficient, it's effective. You know, you got that whole assembly line thing that Ford came up with. That applies to most things. When you give people specified tasks, things work quicker and more effective. So, all that to say, all right, you're going to need to open a Google Sheets. I don't care where you open it. You're not going to be turning it in. It doesn't matter. You can open up an Excel document if you prefer. That's fine. I really don't care. Both will work. But you're going to also, someone needs to navigate to web course, and I'll talk about it at some point. You're going to open up a Google Sheet, and you are going to make the following really, really simple thing. This is me just testing everything. So, this lab today, you are going to be dropping a coffee filter from 10 heights. I do not care what those heights are, as long as they're not all the... I'm going to say, can they all be the same? At least pick a few different ones. Don't just do the same height 10 times. But you can do the same height 5 times and a different height 5 times. But I don't care. 10 different heights. 10 different heights. There is meter sticks over in this corner. Hopefully there's 33 meter sticks. I didn't count. I'm really hoping that's the case. It should be. This room is designed for it. And I've got a million coffee filters in this room. I'm going to have you all just drop 1 coffee filter because I don't want to introduce a different variable if people drop 2 together. That could change some of our results. So anyway, and I'll put all this kind of stuff in writing. So, let's put some rules up here. It's always nice when the rules are in writing, right? Moving forward, any lab you all do will have a nice little write-up document that you'll kind of go through, and it'll walk you through the lab and have the specific questions. But for the one today, we're kind of doing a bit off the cuff. So, drop the coffee filter from 10 heights, and it's open there that you can decide what those are, and measure the time it takes to hit the floor. All right, so I've got tape. I've got the meter sticks over there. You all have a thing to stopwatch. That's what you're going to use for that. And yeah, we're going to go ahead and do that. I'm going to give you all. So send 1 person. Or maybe my TAs would even do it. Yeah, send 1 person to grab a meter stick. Send 1 person. Look, I'm going to spread these things out so to make things easier. Boom, there's those. Boom, there's more. Send 1 person to grab one. Make a Google Sheet. Record these in a column called height and a column called time.
How many people are per group?
3 people per group.
What if there's 7 on the table?
You split into subsets. 3 and 3 and 2. I guess 7? Nope.
There's one.
Ooh. Okay. They just joined the random group. Yep. And we'll make it so people can self-decide the groups in the future.
So do I join a?
Yeah. Join a 3? Sorry.
Oh, yeah.
Join it to make it 4.
Yeah.
All right. And we'll go around and kind of check this. Won't take too long. I'll kind of see where we're at in about 12, 15 minutes. If I need to get more time, I will. But for now, first step, measure heights. Very important. Define your unit. What the heck is 5? I don't know what 5 is. Use metric units. I'm going to go ahead and tell you all. Height in meters, time in seconds. Label your columns with that so you don't forget what you're doing. But yeah, this document will kind of exist to help them see how to use equations. I think it'll flip on them if they drop it this no, it flips with it. So they'll probably. Alright. For the stream's purpose, so I didn't realize that I had this blacked out, but what we're doing at this point is we're dropping a coffee filter in class from 10 different heights, and they're measuring the time it takes for it to fall. So people in class have split up and gone ahead and grabbed meter sticks and coffee filters to do so. If you're at home, maybe that's something you can do, but the thing that'll be interesting at this point for everyone is we're going to walk through how to analyze that data, so that'll be something after some amount of time when students have completed the data collection.
Where did you say the meter stick was again?
Hopefully in that. Oh, there's one left. Thank you. Yeah, I'm hoping you're the only group missing one. If not. Make sure you all record your time to the 2 decimal places that most of your phone has, because if you round, we're going to lose a little bit too much information in this. So record as much accuracy as your tool can provide, which in this case is 2 decimal places, even though you are not nearly that accurate with it. Also, if you haven't realized this, make sure you're measuring height from the bottom of the coffee filter, because when does it hit, what part of the coffee filter hits the ground? The bottom. So if you're measuring height from the top, you're neglecting a few centimeters, or you're adding actually a few centimeters you shouldn't.
I am one class
The next step, if you are wanting I'm gonna get you up to about 9:45, and hopefully you'll have your data done by then. There you're done, great. Your next task, if you want it, is to try to make a graph of that data. I will show you how to do it, but you're kind of ahead. See if you can figure out how to make a graph of this data. It's meaningful. That'll be the next skill I teach you all.
So just put this, and then we do
'Cause no wire is no spot. And we'll see that. Just expect us to be expect comfortable data collection. Don't go for perfection. Right.
I don't use Google,
All right.
talking to her to get jobs at Lockheed.
I'm gonna steal your all's data.
Okay.
Don't worry, no one will know it's your data. So if it's not like, if you're like, oh no, it's not good, it doesn't matter to me. I just need something. Yeah. What I recommend doing. Oh, no, I should point this out to everyone. In your all's columns, make certain it's just numbers. If you added the unit after your stuff, remove that because that's gonna mess with how you. The next step. So make certain in your columns it's just a number, and the header at the top has the unit on it. There's a reason for this. If you put a letter after it, you've turned it into a string instead of a number. And so if we try to analyze that data, it will not know that it's a number. It'll think it's a string. For those that know any programming.
I agree. That's why they're not like that. That's the most important value.
I'm like actively editing while you're typing.
That's fine. That's fine. I'm not copying. I'm just copying the numbers.
You're going
Is that
by
40?
20.
We go to 40, right?
No.
Yes.
I think it's 60. Give me 6.
In calc-
from this class,
go down
went to Cal 3, and he's like, all right, so we're going to be doing vectors today, guys.
40
and we're
should be
doing the same, like,
It's here,
It'll deviate really quickly. It won't maintain. No, Calc 3 though is, in my opinion, was pretty easy. Calc 2 is not a good time. Calc 3, you do like double triple integrals, which is it's literally just doing multiple integrals. Like it's not as bad as it sounds. So you'll have like a function with x and y. And so if you have a double integral, you'll just like take the integral with respect to x, to pretend like y is a constant, and then you'll take the integral with respect to y. And that's a double integral. Like they're super easy, but they're super important and useful. It's 3 dimensions. All right, so we actually still have 2 more. All right, you got 2 more minutes for data collection.
You got 5.
And then I'll move on to the next step.
I can have some tables that do
I think the word.
So if you want to use something else or make sure that you want to
No, because there's lots of reasons why this is graded. I would like to figure out how to make some kind of courses that don't fit. We'll have to make something moving forward. The last one I heard is listed of like different questions that'll have to really be organized for this. The other thing is keep working. It's useful, but all right, let's do it, y'all. So I got some data from an anonymous group, and the reason I got this data is because now I'm going to show you all a few things. We're going to now analyze this data. We have height and we have time. We're going to generate a graph because graphs let you get a visual, like it's like drawing a picture of your data basically. Graphs let you get a visual representation of this. Now, the question is, what kind of graph do I want? So in this graph, it's all based on your goals. And I'm actually going to generate over this class a couple different types. The first one we're going to do, though, is called a scatter plot. We're going to use a scatter plot because we want to see as height changes, how does the time change? That's the purpose of this one. As the height changes, how does the time change? And so I'm hoping I put these things in the right column. I'll find out real quick if I didn't. So how you're gonna, and I'm going to show you this in Sheets and Excel. Moving forward, I will probably just use Sheets. We'll see. We'll see. A lot of there's Sheets and Excel are very similar. There is some differences specifically in, just where the buttons are. That's really the difference. They can do pretty much the same things. So I'll show you all first in the sheet. So you're going to hit Insert, and you're going to hit Chart. And Google, this one, you don't even kind of decide. It just kind of decides for you. Now you can change it. All right. Now, my columns here are not in the order I want them to be. So I actually made a mistake here. I wanted height versus time. I wanted height to be my, and you're going to see why in a second. So I'm going to change this. Really straightforward. How do you change it? You copy this column. Boom. Drag it over. Easy. Insert, chart. There we go. Now my height's on the left and my time's on the right. So the order of your columns matters. I made a mistake when I showed you all the column order. But hey, this is a good exercise, and if it's not the way you want, just move the column over. It's good to know that. It's good troubleshooting. All right. And you can change. And look, it automatically assigned this. It actually put the label here for you. How nice. All right. If we are in Excel, for those of you that are using Excel, I already have this here, but I'm going to, same thing, swap it real quick. You can drag and drop things. If you didn't know that, there's a little arrow, or you can Control X, which is cut. Oh, there's a lot of shortcuts you're going to see me doing. If you hold Shift and you click something, it highlights everything between those two cells. I also want to point out something, and this is just a quick mention. I learned this when I was in my later undergrad classes. I was using Excel, and I was like, great, I've used Excel before. I know how to make graphs. And then I had a data set with like 2,000 data points. And you know what's fun? Scrolling down to find the last data point when there's 2,000 of them. It's not fun. So let me show you all a shortcut I learned in my upper level undergrad. If you have this cell highlighted and you hold Control Shift and you hit the down arrow, it goes down to the last filled data cell. Super handy when there's 2,000 data points. And then I can hold Control and Shift and click to the right, and boom, it goes to the farthest thing to the right. Super, super handy shortcut. Shortcuts make your life easier. You don't need to know them, but they're nice to know. All right, great. Then you go to Insert. You go to this, the scatter one, the one that looks like a bunch of dots. You click the button. Now, I don't know why this is, but Excel is kind of more of a pain. So you notice in, let's just go back and forth. This one did not label the sides for me. And Google Sheets did. So that's, you have to kind of go manually into Excel and add the column titles. It's kind of a pain. I don't know. Maybe one day they'll change it. So Google Sheets automatically realized I had labels here. I did the exact same highlighting and it thought it was the title. It's unfortunate, but it is what it is. All right. But you can see here, let's pull these side by side. One way or the other, at least they're the same graph. Let's see, boom, and stop me. Boom. All right. There's this graph. There's this graph. Look, they're the same. That's all I wanted to show you all. All right. We have a graph, and we have a nice little trend here that as height goes up, time goes up. That makes sense, right? Our graph makes sense. Now we get some different things here, and that's kind of interesting. You know, they're not all in the same spot. The next thing I'm going to show you all is how to add a trend line. We see that there's roughly a pattern to this, that as height goes up, time goes up. So how are you going to add a line that this seems to be a linear relationship? Depending on the variables you're collecting, it could be linear, quadratic, logarithmic, all the things. How do you decide that? You look at it and you have a good recollection of what they look like. Linear means straight line. This looks like a straight line. We're going to talk about what that straight line represents in a second, but for now, you can double click these data points. So I just double clicked it in Google Sheets. In Excel, I hope it's the same thing. Again, this is the fun of me having to go back and forth between the two. So you're going to double click it, and you're going to scroll a little bit, and there will be a little box here that says trend line. And you click that, and woo, it makes a nice little line. It fits a line to your data. Handy. It gives you the nice, based on this is kind of the line that best fits your data. And even cooler than that, so it's linear, but remember, there's all different types. If it's exponential, you would change that. It generally tries to predict what type it is. And then there's a couple things you can do in R squared. R squared is how well this line fits your data. The closer to 1 it is, the better your match is. So that tells you kind of how accurate your trend line is. Yeah.
Well, actually,
Yeah, so there's a yeah, the question was, why was time on the x-axis? And that's a great question, because technically your dependent variable was your time, and generally we put the dependent variable in there. I purposely put it here because the slope has a meaning. And yeah, so that's a great question. Why did I put height here? We'll see in a second. We'll see in a second. The slope of this line means something, but I had to put it in this way for it to be accurate to what I want it to be. So, great question though. I'm very glad you asked that. All right, so speaking of that, I want to figure out the slope of this line. How do I do that? In Excel, you hit this label button. So in the same place you have trend line, you hit this, and you hit use equation. And ta-da, it generates a linear, it shows you the linear equation, y equals mx plus b. The slope of my line is the variable in front of x. That's my m. It's very hard to see here. You can click it and make it hopefully bigger. Bam! So, I'm going to kind of try to fiddle with that. I'm going to go to Excel and kind of show people the same thing. You double click your data and fingers crossed. Ugh. I've got to hunt it down. Okay. If you are in Excel, you hit this little plus sign to the top right and you hit trend line. If you want to see stuff about it, we got to hunt that down. That's going to be, hopefully I can just double click the line and that'll pop up. Fingers crossed. That's very sad for me. Okay. Format trend line. Yay. Okay, so Excel, you make a trend line. You right click the trend line and hit format trend line. And then you go down to display equation on chart, and it's the exact same equation, and you can do things. I'm going to straight up tell you all, moving forward, I will probably just use Google Sheets. The logic being, once you know this tool exists, you can use Google to figure out how to use it in Excel. Google can teach you things. Once you know the goal, Google, how do I do this in Excel? That's literally how I figured this out during the break. Because I didn't know where the exact buttons were. I knew you could do it. I looked it up. All right, great. So, I want to make certain everyone has this. I have no idea if everyone does. If you don't, raise your hand, and the TA/LA will go around and assist you. Hopefully I'm just assuming you all know how to do it.
I don't know how to do the line.
Yeah. So it's in the browser.
Oh, that's always confusing.
So it's no, you're fine. Don't worry about it too much. Oh yeah, right click, add trim line. Then I'm gonna right click the trim line, add trim line equations. Yeah, right clicking generally. That's if that didn't work, I've the other one.
Okay.
Yeah. All right. If you don't have this, don't worry. In future labs, if I have you do this, the pro tip in this class: if you don't know how to use a piece of technology, ask Google. If I'm not around. Google will teach. If I ask you to do something, just Google how to do this in Sheets, how to do this in Excel. It sounds stupid, but that's how it's how I do it. All right, great. Now we've got a couple more things to look at here. The question is, great, I have an equation. This isn't a math class. This is a physics class. These numbers mean something. So the next question is, what do they mean? And to that end, now we get back to why I had to switch the columns. So let's just think about slope. Slope is rise over run. What's my units for rise? What on my y-axis? What's the units? Meters. Rise, so meters divided by, what's my units on the bottom? Oh, look at that, meters per second. It's velocity. The slope of this line is the velocity of your coffee filter. Look at all these discoveries we can make by analyzing the data. Now, why is it linear? If you all notice your coffee filter, it kind of moved at a steady velocity. It reaches terminal velocity very quickly because its mass is low and it has a large surface area. It's basically a parachute. The purpose of a parachute is to lower things at a steady, slow speed. That's effectively what this is. We'll learn about air drag and stuff at some point in class. But that's why it's a linear relationship. If you dropped any other object, something that doesn't have a large surface area, you would not get this graph. We'll see that eventually. Maybe. Probably. Definitely. All right, whatever. Okay. To that end, there is something I want you all to do now. A couple more skills I want us to calculate. And then we're going to do some, what do they call this? Whenever, I'm going to get data from every single group, and we're going to put it all in one big document. It'll be a good time. And there's a reason for that. So, you can look at this data, you can kind of see where your inconsistencies are, you can see where your outliers are. One group I was passed by, and it was really interesting, they're like, ooh, this data doesn't look good, should we delete that and maybe do a new one? A good rule of thumb, always keep all your data. If you're unsure, just take more measurements. Then you can look at all your data and spot the outliers. It's never, you generally don't want to just delete data unless you have an easy justification. How do you make sure your data is accurate or inaccurate? Collect more of it. It sounds stupid, but that's what you do. If you don't see a trend, if you see stuff sticking out, that's kind of an instance that something's wrong. All right. Next thing I'm going to teach you all is equations. Again, some of you may know all this, but I don't know your all's experiences. I have to teach, assuming that people have not used Excel too much. I'm going to teach you how to use equations in Excel because they're super handy. So we just mentioned that the slope of this is velocity. We can actually calculate, or speed in this case, because it doesn't have a vector, it doesn't have a sign. We'll talk about speed and velocity next week. Let's calculate it for every single measurement you took. So I want you all to make a new column called speed. Make a new column to the right of it called speed. And put the units up there. We know it's going to be meters per second. Let's calculate it. For each of these rows corresponds to a measurement. That's a really common thing in data analysis. Every row of an Excel sheet is a new measurement. In my grade book, every row is a new measurement. It's you all. Every row is a new person. That's a really common way that data is organized. So, here's what you're going to do. Anytime you want to do an equation in Excel, or Google Sheets, what I'm about to show you is true of both. You hit the equal sign. That tells it that I'm going to do some math. I want it to calculate for me. So you're going to put an equal sign. Now, you could do this. I could type the numbers. I want you all to take this number, 1, and divide it by the time. And you could type that, but that's inefficient. That's inefficient. So what I'm going to show you all, first I'm going to set the font because I'm tired of resizing it every time. Equals, I'm not going to type this 1. I'm going to click that box. And it now knows to take the value from that box and put it there. The division sign is the /. And I'm going to divide by the time. I then click the time. So I don't know why it made it so small, even though I told it not to make it small. But what I did here is I hit equals. I click the height box. Divided by. I click the time box. I hit enter. And Google Sheets is smart, and it knows I want to autofill and do that for all of them. So instead of having to type the numbers every single time, equals this divided by this, hit enter. I'm actually going to tell it to not autofill because I'm going to show you all how to do that yourself. So equals that divided by that. Yeah, because we're about to combine them all in one data set, and your data will look at the function. Just make a new column. Make a new column and call it type readers, and then you can do equals that divided by that. Well, I think it's, yeah, that's, oh, yeah. Yeah, so, in Excel, great. Excel, Google Sheets, you made one data point. Now, say I want to do that for all of them. I don't want to type that 10 times. That's a lot of work. I don't want to click a bunch of things. See this little box here? You have a little like black square or circle thing. You can click and drag that down, and it will automatically recognize. It will automatically adjust each of these to do it for the one next to it. Now, sometimes that's what you want. Other times you don't. If you don't want to in future stuff, that's a whole process in of itself. But in this case, we do. And you know what? If you want to be even more efficient, just double click it. And it automatically will go down to your lowest data point. Again, such nice things here. Automatically calculate so many things. It's so nice. It's so wonderful. All right. Now, we're going to analyze this data in a couple ways. So we have a bunch of speed measurements. When you all dropped your coffee filter, you hopefully realized it was moving at a fairly constant speed. And I'm going to straight up tell you all that speed should have been the same no matter where you dropped it from. It reaches terminal velocity fairly quickly. So this number should, if our data was perfect, it's not. You're using a stopwatch. You're eyeballing it. Like you're using your thumb to push a button. This is another thing to think about. How could you make this more efficient? That's what experimentalists do, is how do you make things more accurate? Maybe you could have done a video of it, and then you would have had the exact timestamps. Maybe you could have had a standardized coffee filter approved by some government organization that meets certain criteria. Like, it sounds stupid, but that's what... You can buy a standardized jar of peanut butter from NIST. What is peanut butter? You have to actually buy a $1,000 jar from the government organization that meets certain criteria for what is peanut butter. And all peanut butter companies have to compare their peanut butter to that peanut butter to make certain it is peanut butter. Because what if someone sold you peanut butter and it was made with almonds? That peanut butter? Anyway, standardization is an important thing. Whatever, it's interesting. All right, next thing I'm going to show you all is how do we know this should be an average value. Let's calculate the average. Now, you all know how to do average. Hopefully, you add up all the numbers and you divide by how many. I am not going to hit equals and click plus, click plus, click plus. Turns out that averaging numbers is a really common task that people have to do. So, in Excel, in Google Sheets, oh, look at that. Everybody knows I want to do it. You hit equals, and you type the word average. And you put a parentheses. And then you select all the data that you want to average. You close that parentheses, and boom, there's the average. It's a little different than this one because this didn't do the average. It fit a line, but it's close. It's similar. So, to show you all that again, delete. You always start an equation with an equal sign. Equals. And say you really don't like the word average. Sometimes they use the word mean. In this case, they don't. Depends on the function. There is a ton. There's an average A. There's an average here. I don't know why these are different, but average if, average weighted. Rule of thumb, if there's something you want to do with your data, ask Google how to do it. I want to average stuff in Excel. It'll generally tell you, but in this case, I'm telling you the average is this. Let's look at Google Sheets. I don't know if theirs is average or if it's mean. It is average. How kind. Sometimes it'll be listed as mean. All right. Fantastic. Average. Parentheses. Click highlight all the data you want to average. Dunzo. Awesome. There's your average. That's helpful to know. You can imagine all sorts of cases where you want the average of your data set. The other thing we want, it's one thing to know the average. So that kind of tells you, for example, in this class, I might want to know the average score in this class because that gives a sense of how people are doing. But I also want to know the distribution. I want to know how spread out that data is because there's accuracy and there's precision. How accurate? Is my data really tight? Is all of it really close? Or is it really spread out? Like I have measurements all over the place. One of the easiest ways to do that is standard deviation. If you took a statistics course, standard deviation is for a normal curve. One standard deviation away from your data includes generally 63% of your information, I believe. 2 standard deviations is it 66? It's off the top of my head. I don't remember exactly, but it includes most of your data. 2 standard deviations is, I'm hoping, 95% of your data. 3 standard deviations is 99% of your data. It tells you the spread. So, standard deviation, very, very handy. We're going to be using it. So, standard deviation, STD. Fun, right? StanDev. You click that, you highlight all your data. Boom, that's the spread of it. 60 whatever percent of my data falls within 0.17 of that. I'm going to show you all visualization of this. Right now, numbers are hard for you to visualize, but I need more data for me to generate a visualization. So that's the next step. So for now, average, standard deviation, and then I have one last thing as a class that I want us to do. Crowdsourcing, that's the name of it. We're going to crowdsource some data. You are my crowd. I am going to source data from you. So what I need you all to do is I need you all to go to web courses. And is the modules tab even available? Doesn't seem so. Yeah, if I publish this, does it open up? No, I got to make it visible for y'all. All right. So, go to our web courses. I'm going to make the modules tab actually visible. Because as it is invisible. Look at all the things I could make you all look at. All right, so find the modules tab. It will be there in 5 seconds. We'll see how quick things update in web courses. No content, that's a lie. I just made content. There we go. All right. Fingers crossed it's visible now. I need this to work. If not, I'm going to have to do another solution. Oh my gosh, is it still not visible? It says no content. This is lies. There's content. All right. Assignment. I'm going to make up an assignment that's not due at all. Made up. All right. Does that count as content? If not, yay, look. Turns out pages don't count as content. The things you learn. All right, so go to Lab 0 Data Input, and you are going to be taken to a file. It's the one I've been working on. I'm going to move things around so we don't accidentally make a mistake. And we're going to crowdsource some data. Let me actually adjust the columns of these because I realized after the fact. Boom. Look at all these anonymous people that are joining my group. My thing. I want you all to copy and paste your data. Don't overwrite someone else's, so that's going to be a fun time. I'm sure that's going to happen. Look at that, it's happening. So do it below theirs. And I am going to collect. So instead of having only 10 measurements, I have now generated 330 measurements. The more data you have, the more confidence you can have in your results. We'll see that in a second. Assuming your collection instruments are accurate. Lots of assumptions here. But yeah, you get the pleasure of scrolling down.
Or you can just like control down.
Control down does jump to the lowest cell. That's a nice little shortcut. Control down jumps to the lowest one. Control shift down highlights the lowest, everything's the lowest one. But I should have 330. Is that accurate? 10, 33 groups? Yeah, 330 data points. Oh, don't copy and paste your averages and standard deviation. Don't worry, if you did, it'll get overwritten by someone else anyway. All right, I'm going to delete the random people having averages. Clean up some of the data. Sometimes when you crowdsource things, this happens. Ooh.
Actually made a chart.
Yeah. Well, oh my gosh, what's this one?
Oh, the height.
This one has things in it. Oh my gosh. This is good practice in copy and pasting data. This is fine. This is fine. Yeah, that one we're gonna have to clean up a bit. So this one's, that's okay. That's okay. Look, it's all anonymous. There's no shame here. All we know is a raccoon did it. It's fine. Yeah, so highlight there. Yep. Not the average standard deviation. All right, how close are we getting? I'm looking for 330 data points. I'm still shy about 90 of them. So this one, just, that's not going to work. Like that. That one's also bad. Remember, make certain your first column is height and your second column is time. And the good news is, if anyone does anything crazy and deletes everything, there is Control-Z. But, yeah, make certain your first column is height and your second column is time. Or, sorry. First column is time, second column is height. First column is time, second column is height. I am realizing... Ooh, what font is that? Shadows into light, wow. Doesn't matter what font it is. Excel knows it's a number. That's all I care about. As long as there's no words in here, we're in a good spot. All right, I'll give like a minute or two more, and then we're gonna look at some things. It's not critical I have all the data, but again, this is gonna show some aspects of data collection. Ooh, that's fast. All right, I think this one forgot to. Anonymous Python, something's not converted here. I'm fairly confident we should have decimals in front of those. Yeah. But you know what? I am going to leave it for a reason. I'm not... It will actually be to my benefit if there's some data here that's input incorrectly, because we're going to get to see that data in our visualizations. How do you identify if you have good data? That's a thing. So I'm actually going to be happy if there's some data in here that's not great. Oh, look! Somehow there's already a graph in here. Someone's made one for me. I don't know if it includes everything. Yeah, right now there's a lot of power. So you all have edit privileges, which is always dangerous to give 99 people. But I trust y'all. Okay, we're going to call this good. I'm going to go ahead and delete this graph, not because it's... You know what? Someone worked hard on this. It's just going to go down here. It doesn't want to go down here. Okay. There we go. All right, so remember, I don't want to scroll down and select a bunch of data. So what I do is I click here, I click Control, I hit Control Shift down. Bam, it's all selected. Actually, it's not all selected. There is a giant void. That's okay. That's okay. What do you do in the solution? You just hit Control Shift down again. It jumps to the next one. Nope, that's not everything. Hit it again. Hit it again. Hit it again until I finally reach the bottom. How do you know when you reach the bottom? If you hit Control Shift down again and it goes to 999, hit Control Shift up and bam, problem solved. Great, I got all my data. Insert. Gonna insert that chart that someone already kind of did. We're gonna hope that it pops up at the top. It didn't. It's probably at the bottom. Ooh, that's not the one I want. That's a line chart. Bad. So I'm gonna tell it what I want. Oh my gosh. Yeah, so this very likely, I don't know why it looked that crazy. Yeah, people are making all sorts of crazy charts in here. All right. Yikes. All right, whatever. Now it works. I don't know exactly what happened. So look at this. This is kind of interesting. We get some clumpings of data here. We have like a clumping here, and then we almost have a second group here. Why might that be? It might be that some people measured height from the top of their coffee filter. Oh. I don't know what happened. All right, at this point, stop fiddling with things because it's going to just make it a mess. All right, so pause on any data adding or data manipulation. If you want to make a copy of this and fiddle on your own, go for it, but I'm just going to avoid for the sake of time, otherwise I'm going to keep hitting Control Z. All right, 2 clumpings of data. That means that something was different. That's interesting. You can, as an experiment, you can think about why that might be. Maybe you change things. We can add our trend line, great, all that kind of jazz. The next thing I'm going to do is ultimately what was the purpose of this experiment. One of the purposes was to measure the speed. So I want to see this distribution of speeds. I want to see how accurate it is. So what I'm going to do is I'm going to highlight all the speeds. And if I want to see a distribution of speed, I am not going to use a line chart. I'm going to use a completely different type of chart. And it's going to look all crazy because we have some funky data here. If you only select one type of data and you want to see the distribution, the graph of that is called a histogram. A histogram shows how often a data set occurs. And it groups things by bins. Okay, it didn't know that. That's all right. Where's my histogram? Boom. Look, you get to see a distribution of the data. You can change these bins. So data that was between 0.58 and 0.77 fit here. The more data you have, the tighter this thing tends to get in general. Or at least the more accurate it gets. I should say that. The more accurate your data is to the real thing. So we get a somewhat normal distribution. Again, you can change your bin size somewhere, depending on the function, depending on Excel or that, depends on where that is. I'm not going to worry about it for now. But yeah, this shows the distribution. I will use this to show you all your test scores, to show you all a sense of how you scored compared to other people. I use histograms all the time to analyze data and see what's the average, what's the standard. It's a visualization of that. Last thing I want to point out. Last thing, and then we're actually, I think, going to be good for what I want to get done today. I am going to calculate the average down here of everything. Boom, there's the average. It's very high. Why? We have outliers. We have some heavy outliers. You can actually see them here on the bottom. These might be the reason. There might be other reasons. Let me just delete these from that. We get a little bit closer. 4 meters per second is, we already know it's too quick. Why do we know that? Because when we look at our histogram, the average, the actual kind of average was 0.6. There can be things that the outliers will stretch your average in ways you don't want it to. So that's one thing. The next is the standard deviation. Let's go ahead and calculate the standard deviation of this data. Boom, 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 all the way up. It is wild. It is wild because, again, those outliers. The outliers are dragging our data. I'm not sure which outliers exactly, but again, oh yeah. No, you can't see it here. So, this is helpful stuff. Anyone can go out there and collect a bunch of numbers. What you get paid for? Physics is on, yeah. We'll see. Hopefully it won't be too bad. All right, I'm going to remove edit privileges. It's going to get a mess. You can view now. You've all lost powers. There you go. I'll leave that. That's fine. I don't really care. Maybe I can change that person's mind. It's one thing to collect data. It's another thing to be able to collect data accurately. Those are vastly different things. And you're getting paid not to just collect a bunch of numbers, but to do a good job of it. So, all that to say, that's what you'll be doing in the labs. The reality is most of the labs is not discovering physics. Like, someone's already discovered the physics. Yes, you will get to see that the things I'm teaching you are accurate, but really more what you're going to experience is what it's actually like to collect data. You're going to run into technical difficulties. Your device is not going to work the way you expect it to. There'll be slight deviations in how different physical devices work because the world has slight deviations and every single human in this room is different. Every single meter stick in this is not the same. Nothing in this world is identical to each other. Nothing. 2 grains of sand are not identical. In the entire world, you're not going to find 2 grains of sand that are absolutely identical. So, this is the purpose of labs, is to experience collecting data, analyzing data, getting a result in the midst of a real world that's messy. How do you do it well? So, we'll do that. At this point, I know we have a good amount of time, and so this may be a trend moving forward where I finish the class, I've covered what I want to, and I could jump ahead and keep going and all that kind of stuff. But at least what I'm going to do today is I leave it up to you. I will be in this room for the next 30 minutes. You all have a quiz that's going to open up tomorrow at 7 on vectors and units. So you have the option to stay in this room and like work on those, and I'll be available to help you, or go off and work on it somewhere else or do whatever the heck you want to. I don't care, but I can promise you the LA and the TA will be here if you want to continue working on things. Basically view it as, it's not office hours, problem solving session. But we've accomplished what I want to for the minimum for everyone. So if you want to stick around and solve problems and ask questions, I'm here for you. Otherwise, you're free to go. The quiz will close not this Saturday. The quiz will open tomorrow at 7 a.m. and will close on the 31st. A week and a day. A week and a day. You can keep the coffee filters if you want. I don't really care. The meter sticks, please do put those back. Yeah, coffee filters, treasure it forever or throw it away. I don't really want them back.
So yeah, thought about it when I went home. I ended up just making the change myself.
To